going to start with here is I'm going to write down, we got that equation. So you guys wrote that in lesson 2. Does everybody remember that?
Yep, I do.
And that equation is really good for finding what? The number of what? Edges. How do we know that's good for finding the number of edges? Ivy? The E is isolated. It's like E equals this thing. Okay? So down here, for number 1, it wants us to find the number of vertices. So we need to change this equation instead of being solved for edges for vertices. So I'm going to rewrite my equation right here. And we also have learned the last couple lessons, Cam, that we can make equivalent fractions by doing the same equivalent equations, not fractions, by doing the same thing to both sides, correct? So this looks like we need to get what letter alone? V.
Let's go.
So Kai, how do I get rid of the F?
You subtract it on the E.
I subtract F from both sides, right?
Yeah.
And how do I get rid of the minus 2?
You have to.
So that's why I'm going to kind of do 2 steps at once here. Those would cancel. And I'd be left with B equals E minus F plus 2. So is this equation the same or different? It's different but equivalent. Yeah. Yeah, but it is kind of the same then. It's the same thing, only different. Now, let's look at the information we know from our situation for the 8-faced octahedron. Where in here would I put that 8 then? Yeah, so I put an 8 in here. I have 8 negatives and 2 positives. That would total what? If this is a negative 8, yeah, negative 8 plus 2 is negative 6. So I have the equation for my octahedron. The volume is equal to E minus 6. So what I did is I manipulated my original equation to be solved for the vertices and then substituted the information I knew, 8 faces. So what's a little different about B? What information do I know from B that's different? Yeah, so JP, where should I put that? Where should I put it, JP? Yep. So if I go 30 minus F plus 2, I can combine my 30 and my 2 to make what? 32 minus F, right? So V equals 32 minus F. Cool. So let's talk about these buckyballs, the fidget spinner of 6 years ago, right? Was that big in elementary school, the buckyballs for you guys? Okay. So this tells me the number of vertices, but it's looking for one that makes it easier to find faces. So what variable do I want to isolate now? F. So looking at this equation, how do I get rid of the vertices? Minus V. And how do I get rid of the minus 2? Add 2. So that gives me the number of faces equal to edges minus vertices plus 2. The next thing I want to look at is the information I know. The information I know is that I have 60 vertices. So I'm going to slap that in right there for vertices. So negative 60 plus 2? Negative 58. So negative 60 plus 2 is negative 8. So that's all of them. All right, so I pretty universally saw this equation for the equation to be used. I saw something like 21,600 pounds. We got there by doing 3.6 for each car and 7.5 for each truck. Okay? Now, here's the most common way I saw people do A. I saw them use that equation and say 21,600 equals 3.6 per car plus 7.5 per truck. And there's 480 trucks. So this is the most common thing I saw for A. And then from here, I saw them multiply the 7.5 times 480 to get 21,600 equals 3.6C plus, what is that? 480 times 7.5. 3,600. Okay. And then, so this makes sense in context, right? Total weight is equal to 3.6 per car plus 3,600 tons in trucks. So if I take the 3,600 pounds tons in trucks away, that leaves me with 18,000 pounds that I can put 3.6 ton cars into. So if I divide that, how many cars we get? 5,000 cars. In fact, here's something else I saw in the other classes I loved. Check this out. Look for the difference. I'm going to do it right here. The thing I saw other classes do is this. No, other way. They could have up to 21,600. I saw some people using inequality today, and I like that too. Now, if I had to do this for 1,500 trucks and 2,736 trucks, I totally can. And it's not too hard. But what I directed some people to that I saw doing this is, what did we do for the warm-up?
We did change out the equations.
We made equivalent equations to isolate the variable first. So keep your 5,000 cars, but let's try that for B and C. So if we started with 21,600 plus 3.6C, no, not plus, equals, plus 7.5T, I know the number of trucks, I want to find the number of cars. So look what I can do if I solve for trucks. Minus 7.5T, if I solve for cars, sorry. So 3.6 per car equals 21,600 minus 7.5T. Divide by 3.6. And now I have myself an equation. Cars is equal to the total weight. Take away 7.5 tons for each truck over 3.6. Okay? So now what I could do is watch this. I could take the number of trucks, slap it in there. The number of trucks, slap it in there. Number of trucks, slap it in there. And how many times did I have to solve the equation this way? Just once. And solving the equation, while not crazy, it is work. Okay? So, so if we did this, are you guys seeing like you could just slap the number of trucks in there and be done? Kind of like the warm-up with our faces, edges, and vertices. Right? So someone, just for the purposes of answers, we had 5,000 cars for A. How many cars for B?
Solving right now. Actually, 2,833.
Can we confirm that for B? I've got it right here. I got 875.
No, don't do C yet. I did not get that. I actually got.
For C, I got 300.
Ooh, I got that too.
And for T trucks, I got this. So I actually went to letter D first myself. Next, you're going to practice this if you're loading cars first. So remember, our original was 3.6C plus 7.5T equals 21,600. Instead of loading trucks first, I want you to give me an equation if we're loading cars first this time. So taking a look at this, I heard and saw lots of good stuff around the room. So I'm going to do A right here. And if we know the number of cars, what are we looking for? We're looking for the number of trucks this time. So goal is T equals for trucks equals. So Meredith, how do I get rid of 3.6C? Yeah, minus 3.6C to make these equivalent equations. So 21,600 minus 3.6C. And this makes sense. What this currently is saying is the weight of all the trucks needs to equal all the weight it can hold minus the weight of the cars. Like even our equivalent equations like make sense in context, okay? Then I'm going to divide the weight that's left by 7.5, and that'll tell me how many trucks I can get. So the number of trucks is equal to 21,600 minus the weight of all the cars divided by the weight of one truck. So this would be for A. Okay? Now, how much easier was it to just go bang, bang, put 1,000 in for C, see what you get, put 4,250 in for C. Way easier, right?
Yeah.
So for B, my answers should be 2,400 trucks, and it should be 840 trucks. Okay, and in my money's on, I want these to be that Cybertruck, son. Okay, a ship full of Cybertrucks. Just to make sure we're good to go on. Here's our starting equation. Our price per mile per price per employee totals 1,962,800. So I'm going to start by solving for a P, and then I'll erase and then solve for M. So solving for a P, I'm going to subtract 84,000 M from both sides. And that leaves me with 36,000 per person gives me total budget minus the amount of money I'm spending per mile, which, like, do you see how I keep talking about it in context? It, like, makes sense. And then if I divide what's left by 36,000, that'll tell me the number of people I can hire. So instead of rewriting it, I'm just gonna box this part. Cool? And then, to go back and do the same thing for the number of miles that I can do, I'm going to solve for P. Wait, I'm going to solve for M now. So minus 36,000 per person will leave me with 84,000 per mile if I take the total budget minus my labor cost here. Then divide by 84,000 for each mile to see how many miles I can do. And that's that. Now, we're not going to do this next part just to save a little time because I'm feeling good about where you're at. But if we're looking here, if we know there's 6 new hires, which equation would you want to use, the M equals or the P equals? M equals, because we can put 6 in for new hires. Now tell us the number of miles, right? Okay. So, when's if we knew there are 16 miles, which one would we equal? 6 or M equals or P equals? P equals, because if it's 16 miles that we need to do, that tells us the people to hire to do it. All right? So we don't need to do that. I think that's kind of the easier part. So I want to make sure we got this. Can we write an equation to describe a situation?
Yes.
Yeah, we did it twice today. 3 times almost if you include the warm-up. Also, did we also figure out that we can solve for a variable up front and make things quicker for ourselves? Yeah, by making equivalent equations. We just made life better.
Yeah,
Switching it around, right? Is it worth anything different? No. Left side, right side, still true. But it's easier to use.